Hello, let's talk about everybody's favorite subject, and that is exporting particles out of Houdini to be rendered in Maya for some reason. The built-in Alembic importing tools in Maya are pretty bad, and there's never seemed to be any progress on that front. There's been a solution to this for a number of years now, but it seems that this question pops up quite a lot, and a lot of people are either just not aware that the solution exists, or whatever reason. So I thought I'd run through it today. So we have a simple particle system here. We're just going to keep it nice and light. It's only 2 million points, and just doing a little bit of p-scale variation, some color, and interestingly enough, since Houdini 18.5, now if you have points, and I believe this is probably something to do with the USD side of things, if you middle mouse and check, this never used to be an actual attribute that it had. The points were just points. Now in 18.5 they're called unconnected points, and this causes problems in USD. So I found that what I have to do is just use the good old add sop and add a particle system. So what that does is it says this has got a flag saying this is basically points, and that unconnected point attribute, or whatever you want to call it, is gone now. So that's a little gotcha in 18.5. Anyway, so this is a simple particle system. Nothing magical is happening. It's doing what it's doing. What we're going to do is we're going to export as Alembic because it's everybody's favorite, but we're also going to export as USD as well. So the only thing I'm doing down here, I'm just converting CD over to color and p-scale to width. In USD, when you author USD files, if you have CD on there, it gets pushed across when it's turned into USD as display color to help it be visualized in Hydra, in Storm. So it's an easy way to sort of not lose the attribute, but you now have to type in display color if you're going to use color from the points to using your shader, which I think is a little bit cumbersome, and it doesn't feel natural to be typing in display color. So just converting it to color and width is a little bit more common sense. So we can write out the points here. I'm just going to write out 20 frames, and nothing apart from standard stuff, nothing's being touched here. Everything's being left. The only thing I've got here is the bounding box tree, just to help with viewport and rendering bounding stuff. You can leave it on or off, it doesn't really matter. So we save them to disk, and hopefully it doesn't take too long. Cool. So we're going to write these USD points, these Alembic points out, and then we're also going to go and have a look at USD as well. So the USD side of things, in LOPs, this is actually, if you dive inside here, and you can actually see that it's basically just a LOPnet, and it's bringing, is it not going to die? I hope it's not going to die. Nope, there we go. It's just doing a SOP import and then standard USD output. So it's just a nice little wrapper, which means you can actually still be inside of SOPs and author some USD stuff, which at the moment I kind of prefer, because I think USD isn't always this big scary overhead thing that you can't use unless you're going to use it completely. I think it's got some really good benefits, even if you're just going to use it for simple exporting of point data. So the benefit of USD over Alembic, there's a lot of benefits. I was a huge fan of Alembic and even Alembic layering for a long time, but USD has even the USD format, the data format, it actually reads and writes quicker, and it's, from what I've tested, it's probably about 10 to 15, sometimes up to 20% smaller file size compared to the equivalent Alembic with the same attributes stored on it. So we're in a weird time in computer graphics land where Alembic is proven and it's been around for a long time. It does have a lot of limitations, but the layering is a good way to keep Alembic still quite useful. But I think everyone's going to eventually have to move over to the USD side of things. But I'm going to show both methods here because I think it's beneficial. So writing the USD points out, ticking separate file per frame is super important, because you really don't want to have one monolithic USD file when you're changing point counts. There's no inherent benefit of writing out one gigantic USD file because the point count is changing per frame, so there's no benefit of you being able to basically get deformation blur for free. and also the overhead of writing out this one big file over the network, the chance of it crashing. So I'm still a huge fan of writing out per frame. So USD totally supports writing out per frame. The only problem is that once you write things out per frame, it needs to be aware of that sequence of frames. Basically, you need to use what's called USD stitch clips, and what that basically does is just a wrapper around your sequence of frames that you've rendered out that, as far as USD concerned, is just a pointer. So you can say, okay, here's my pointer file, and the pointer file is a wrapper around that sequence of frames. It'll make more sense when we bring it in. So we'll write these frames out. Nothing's changed here from the defaults except for per frame, and on the configure tab, just relative path prefix. It needs something, so you can have a look inside the docs of why that's important. We're not going to jump into all that rubbish for now, but just that's all we need to do. So let's save that to disk, and saving it out per frame, that means that if this is obviously not tied to simulation, you've already written your sim to disk as BGO, you can break this into chunks if you do it on the farm. So that kind of divide and conquer side of things. Now the only annoying thing is there is nothing inside of SOPs for actually creating the USD stitch clips, and I can't remember if even in LOPs you still have to dive back into the out context, which is super annoying. But I just have a little ROPNet here with the USD stitch clips. Input file, obviously I've just got a relative reference to the sequence of files I've written out. Template file is kind of important, the way that things are, where it's looking and how it's structured. There's no easy way to just create a relative reference, so it can bite you on the arse a little bit. You need to be just diligent in where you're looking and naming things. Same thing with the relative clip path stuff. Default, we don't touch. Matt Estella on Tokaru Houdini has a good little breakdown of why you need to do this kind of stuff, and it's in text form, so you can pore over it a little bit more rather than listening to me ramble on. So I can just render this out. It's looking for that same sequence, frame numbers. We write this out, and what has that generated? Well, if we actually come down here and have a little look, I've got my output. So I have my actual separate USD files per frame for the points, and it's created this bunch of stitched USDs. So this is kind of what I was saying about being a pointer file that's a wrapper around this sequence, so that when it's ingested into USD, it says thank you, and it knows to process all of these together. So that's cool. ABC export, we just got our regular Olympic exports there. So you can see already the same attributes. That's 95 meg-ish per frame versus 79. So obviously you whack another 0 on the amount of particles you have there, things are going to start to creep up even more. So we've written these two things out, nothing magical there. Let's hop into everybody's favorite program, Maya, and what we're going to use to bring it in is a plugin called Multiverse. Multiverse has been around for a number of years, used by a few studios, namely Soho VFX is one of the biggest users of it, and I've been using it for quite a few years as well. What it is essentially a way to, it started out as more of a way to bring in Alembic files intelligently and be able to have them be completely deferred, so they didn't take up valuable resources in Maya, and you had plenty of different viewing options as bounding box, point cloud, hidden, so very kind of similar to loading geometry into Houdini as packed. It's since progressed then to be a completely USD based kind of thing. It's still able to process Alembic files as well as USD native files. Head over to the website, and what they've done in the last 12 months is made it free. Okay, so the free version is usually maybe a couple of point releases back, but it's very, very minor. Obviously you have differences if you buy the pro version, and honestly it's not even that expensive, but you can get by with the free one completely fine. And if you just have a little scroll down, you see it's been used on quite a few things, and what it is able to do is it's able to author USD compositions and files, read them in. It's able to set overrides inside of Maya so that you can bring in USD compositions. You can select individual things. You can apply transforms, shader overrides, render time overrides with a nice, really nice UI, and it's all deferred. So your experience in Maya in the viewport and just navigating around in Maya is very, very lightweight. It makes Maya usable as far as I'm concerned in that front. They have another thing called Muse, which is in alpha, but it's worth mentioning because what Muse is USD View is able to load USD files, but it's purely a viewer and an inspector. Muse aims to be something that's able to load USD files, inspect them, but also author overrides. So think of it as basically exactly what it says, a USD standalone editor. It's not tied to any DCC, so you're able to just fire up a Muse session, bring in USD compositions, edit, override, change without having to go near any applications, which I think is super interesting. And going down through the list is all the typical USD stuff. Variants, instancing, all the point instancing stuff is supported, especially useful, which I'll make another video for, which is if you have RBD destruction. The classic awful way of exporting and even just caching RBD sims is to cache all the geometry per frame. So if you've got 10,000 chunks of geometry and you have 100 frames, that 10,000 pieces of geometry exist on every single frame, and it's insane. It's a huge data overhead and a bottleneck, and it's just a waste of everybody's time. So what I will do in another video is show the USD point instancing, exporting out of Houdini, so that you're just saving one static frame of your rigid body simulation and a point cache, a USD point cache, and you save that out as a USD point instance, bring it into Maya or bring it into LOPS, and it will be super lightweight, and you're talking a massive saving. You basically only have the overhead of that static geometry once. You don't have it once per frame. It's really, really handy. All the usual kind of jazz. And just to allay any fears, Multiverse does support Storm, so we already support Pixar's Hydra, Through the Light, Arnold, Redshift, RenderMan, V-Ray. They're all supported, and it's fantastic because it means as far as you're concerned inside of Maya, you can bring in USD assets or Alembic. It's completely deferred, and the Multiverse plugin, the translator, will actually translate on the fly to your renderer. So it's able to take the heavy lifting out of the equation. So there's nothing for you to do. And what it also has is a really nice Python API that abstracts away the low-level complexity of USD, which I think, if I'm being honest, that Solaris is a little bit too exposed. Solaris is essentially a one-to-one mapping of USD, so all the insides of USD and all the complexities are completely exposed to the user, and I think that's half the problem with people not really wanting to dive into it and also feeling quite lost. What the Multiverse API is doing is abstracting away that level of complexity, so it's essentially an interface between you and USD. So you're able to have a much nicer experience being able to construct a pipeline around that level of abstraction, and there's not a need for you to dive in to the entrails of it, which I think, it's part of a different conversation, but it's interesting. And I'm a big fan of simplifying things. So anyway, that's enough of Multiverse overview and the awesome features that it has, which, you could spend the time and read because it's really, really cool. Okay, so we're now in a Maya session, and with the Multiverse tab loaded, we have all of our standard kind of stuff here. We're able to write compositions, overrides, we're able to read in, and when we've read in stuff, how do we want to do? Do you want to have bounding boxes, proxies, if you have proxy USD stuff authored? Do you want it to be shaded? These are basically your viewing options, but it's all deferred anyway. You then have built-in options at the moment to toggle between using Storm or Through the Light in the actual viewport. Some controls for setting and overrides. The Multiverse UI for editing USD, so setting transform overrides, shader overrides, all that kind of jazz. A handy little built-in launcher for USD View, and just links to the docs. Okay, so if I want to go to my importer, okay, what I'm going to do first off is I'm just going to import the USD points. So these USD points, we wouldn't be selecting these, we'd be selecting the stitched file. So this you can safely ignore, it's a Houdini thing, which I should probably author this properly so that you have a default prim. That's fine. I'm letting the default thing be a shaded view, that's fine. Let's open it, and that's instantaneous. Okay, so we now have our 2 million particles or whatever. I've had 10 or 20 in here in the viewport, and it's been fine. It's been very, very simple and easy to move around. And because the width attribute's in there, it's actually visible in it's Hydra in the storm. So at the moment we're in storm. Okay, by default we're already in storm. So that's cool. This is an Arnold scene, so I thought I'd show you that it's really straightforward to get it up and running in Arnold as well. So if we have these guys selected, I think if I can assign an existing material, I might even have an Arnold shader in here. Oh, amazing. Okay, so I have a simple Arnold shader in here. I don't even think, whoa, let's close that down. We don't care about our output window. Let's launch an Arnold render and see what we get. Okay, so this is translating the USD authored out of Houdini straight into Arnold on the fly, and you can see it's pretty good. Feedback is really good, and the P scale, which we obviously converted to a width, is there, but you'll notice that it's not rendering as true spheres, and that is more of an Arnold thing. So if we come down here and we go back, whoops, let me select that again. We go back to the shape node here under this tab for Arnold. Take the translator and set it to points and set the mode to sphere. So now we have nice proper spheres, and off we go, and we're rendering, and it's pretty neat. So I think it's super handy. So obviously you still have control here for scale multiply stuff, which is nothing super unique. But on the Arnold standard surface, what if we want to actually pull in that color attribute that we had? So we can just come here, like everybody knows. So if we go Arnold utilities, and I think it's user data color, cool. And we know that we called this attribute color. So there we go. So that's how easy and simple it is to simply author some USD points, bring them into Maya via Multiverse, and obviously, you know, if you had a complex scene, you could turn around and say, you know, I don't even want to see these things. I just have a bounding box for them, and it takes my overhead down. Cool. So I think that that's super handy. So let's kill that. Now, what I do want to do is just delete that, and remember that we authored out not only these USD points, but we also authored out these alembic points. Now at the moment the alembic is just a simple alembic sequence. The USDs have the actual stitching done on them. So you can wrap up the alembics, and just like we wrapped up the USDs, and stitch them in Houdini. But I wanted to show a nifty feature in Multiverse, and that is that if I select my alembic points, I can just grab any one of these. There is an option here to generate USD clip. So what we just did in Houdini with the ROP to generate the stitch clip, Multiverse has it built in for you here. So Multiverse is completely USD based, but it totally supports alembic, but the alembic sequence of points that we have here, they just need the wrapper. So this is a nice easy way to do it. You could do it in Houdini, but I thought it was nice to just show this as well. So we're generating this. Cool, so that's automatically been generated. We can just grab this, open, and here we go. We have the same alembic points in here, and same thing again. If I just assign existing material, Arnold, and tab over to Arnold, and let's kick off Arnold. There we go. So we have alembic points stitched together and rendered in Arnold, which I think is, oh, why isn't it doing continuous? Ah, there we go. Cool. So I thought that was pretty neat. Now the other thing too, like I said, if you go across the Multiverse tab, you have this Meow editor, and the editor essentially allows you to do a whole bunch of variant overrides, transforms, all the type of stuff that a lot of the time, even though you've done your USD author and you think you're finished, you know, the lighting guys might say, I need to transform this, I need to put some overrides, I need to jump in and put a shader override. It's all available in a really nice UI, which I think was much better than what's built in, which is pretty crappy. The other benefit too is if you have your Multiverse compound selected, just hitting USD view will instantly launch a USD view session for you. So same sort of thing as you're usually able to do. And I think it's great that USD view has been shipped with Multiverse, so there's literally nothing for you to do except download and install it. You have a way to bring in USD into Maya very easily and Alembic points stitched and wrapped up, and you also have USD view already ready to go, correctly configured. It's just making life a lot simpler than it has been, because it doesn't need to be this complicated. So I hope that was informative. Cool.